Welcome to Mrs. Mahoney's podcast. This is our second one in our Unit 8. So I know at the top of the page, around page 7 in our packet, it says more stoichiometry. It is more, but it's not new, not new, totally different. Because in fact, the first step is exactly what we've been doing. We're just going to do an application after we get done with stoichiometry. So you need to get everything ready. You need your periodic tables. Check. You need a calculator. Check. You need your packet. Pencil. Okay, I have my coffee to keep me awake. I really like my coffee. It keeps me awake. Some of you may want to try that when your excuse is I fall asleep. Not maybe start it at midnight might be another thing to try. I think we have everything ready to go, so we're going to look and put some definitions again, and part of it's knowing the vocab. So if we know the vocab, then we know how to use it. Okay, so top of page 7, we've already defined this, but again, make sure you know the difference between these two. The theoretical yield, that's what you've been calculating. Everything you've been calculating for the past 2 days, when you calculate a product, you are calculating, in theory, how much could be produced. Okay, that compared to the actual yield is then what it kind of sounds like. How much do you actually made if you do that reaction in a lab? How much of it was actually produced? So the actual yield is more, if you kind of like this is like the real value. This one is a theoretical. This is the pencil and paper value. And so somebody of you asked the other day, is it just kind of like a percent error? And it kind of is. It is, because it's going to be a reflection of how well you did. Okay, so here's your formula. And it is just the actual yield over the theoretical yield times 100. Okay, now notice, this is on your formula chart that you get on every test. Do I need to know how to, do I have to memorize it? No. Do I need to know how to use it? Yes. So this calculated, this is what you've been working on. This would have to be given to you if I want you to calculate a theoretical yield and just give you, a percent yield and give you some amounts. So let's just kind of show how we would see these problems and how I would recognize that it's a percent yield. Typically these are pretty easy because it's going to ask you something about the percent yield. Versus when we talk about limiting reactants, those you have to look a little bit more. But right now, look at this. It says, what's the percent yield? Okay. Also, it's going to look a little different. Notice I gave you 2 numbers. So this is where you're going to kind of have to say, okay, what do each of these numbers mean? So what is it saying? If 2100 grams of aluminum sulfide are decomposed and the actual yield of sulfur is 1100 grams, what is the percent yield? Look at right here. Actual yield. This is giving me an actual yield. I'll need that, but I won't need it until I'm done. So you know what? Tuck it away. Forget about that. Don't even worry about that number right now. We need it after stoichiometry. So this is what I need. So aluminum sulfide, this is my A. What do I have? Grams of aluminum sulfide, that's my A. And where am I going? Well, look at what it gave me the yield of. Sulfur. So this would be my B. This is what I'm going to. So I know I'm starting with 2100 grams of this, and where do I want to end up? X grams of sulfur. Just kind of organize my thoughts as I'm going through it. So what do I need? Okay, molar mass of aluminum sulfide. If I take 2 aluminums plus 3 sulfurs, 150.2 grams per mole. Okay, notice I'm using 4 significant figures, especially because there's 4 significant figures in there. Sulfur, the molar mass, 32.08 grams per mole. Okay, what do I need to remember to do? Balance. So I feel like there's all this little keeping up before we even jump into it. I make sure, okay, balance checked. I'm just going to go ahead and get my molar masses checked. Okay, now I'm going to start going. So what do I have to do? Grams of aluminum sulfide. Grams don't do me any good. What do we have to do those grams? Change them to moles. So 1 mole of aluminum sulfide is 150.2 grams because I calculated the molar mass early. Now where do I want to go? I want to go to sulfur. So what's the ratio? Well, I get out 3 moles of sulfur for every 1 mole of aluminum sulfide. Now remember again, when you're setting these up, if I have grams of aluminum sulfide, you're going to have grams of aluminum sulfide down here. Moles of aluminum sulfide, I'm going to cancel them out and need to have them down here. So that last step, let's get to grams of sulfur. So 1 mole of sulfur has a molar mass, 32.08 grams. Pull out the calculator. Let's do the math. 2100. And again, when you're setting these up, you can either multiply all across the top, then divide all across the bottom, or you can then multiply, divide. There's some people have different procedures. It's up to you how you like to do it. So if you want to say 2100 times 3 times 32.8 divided by 150.2, or you can say 2100 divided by 150.2 times 3 times 32.8. Okay, have I talked long enough that you finally have your answer? Because what you should have gotten, or how many of you were just sitting there waiting for me to get the answer, going, come on, Mrs. Mahoney, get on with it. Just give me what the answer so I can copy it down and then yeah, so I can be done with it. Okay, so look at what this did. This is your what did you just calculate? This is your theoretical yield. Helps if I could spell, but that's okay. You all know I can't spell. You see, I'm actually not doing too bad. Oops, sorry. Theoretical. Okay, so this is my theoretical. What else do I need to calculate percent then? This is where it's new. After we're done, this is saying, okay, in theory, I should have gotten 1,346 grams out. Let's compare it to what I really got. So I really got out 1,100 grams. In theory, I should have gotten out 1,346 grams. We just times it by 100 to put it into a percentage. So looking at this, notice I'm going to keep these all the 4 significant figures. I have 81.72 is my percent yield. So when I'm looking at these numbers in industry, you want to have a high percent yield. That means you're not wasting any products. Okay, you want a low percent error, but a high percent yield. Now the percent yield still, they actually use this in industry to know how much of my reactants do I need to know how much reactants do I need to buy, because they'll have to look at their yield to know how much can I get out. Now your percent yield should always be lower than 100%, because you cannot create mass. I can lose mass to some energy changes. There's some spilling. There's some that just doesn't get converted because of different react mechanisms, but you shouldn't create mass. Now what happens in the lab, unfortunately, because of some of your human error, things not technically not getting dried or doing some of that, sometimes your results looks like you created mass, but that's where you need to have some kind of explanation of what happened in your lab. Okay, let's just do a couple more looking at these. Okay, so if I look at this 12, you know what? I want you guys to actually kind of do this, and here's like a huge hint that I'm going to give you right now. Hint, hint, hint. If you look back in your packet, and if we look on page 4, look at question number 9 that we did together in class, we did this exactly same problem. So what I want you to do is go back, use that as a guide, and then go and do that one extra step when we're doing this. So this one is on your own. I want you to work on this on your own, and I'll give you the quick answer tomorrow so you can figure out if you got it right or not. But your huge hint, look back at that problem that you've already done, and you'll realize that you've already done most of the work. You just need to do this last step. And in reading this, this is that actual yield. This is saying this is your actually what you made. So you need to go back and figure out your theoretical yield. Okay, so let's look at how some of these problems can look a little different. So I have copper 2 sulfate reacts with aluminum, and it's yielding what? Copper and aluminum sulfate. I want to know what mass of copper is produced at the percent yield. So it gave me this time a percent yield, but it didn't give me the actual yield. Well, look at your formula. So when I know my percent yield, what is it? It's actual over theoretical times 100. So I still need to know 2 out of these 3. So it gave me the percent yield. I want to know the actual, so I'm still going to have to calculate the theoretical. Then we'll just plug it into our formulas to figure out. So I still have all those things. What do I have to do? Balance your equation. So my aluminum's 2. I have what? 3 sulfates, so that means I have 3 coppers. And this excess copper sulfate, when we see words like that, that means don't worry about it. You have more than enough copper sulfate to react with all the aluminum. So I know what I have. I have 2.7 grams of aluminum, and I want to go to copper because it's asking about the yield of copper, so I'm going to go to grams of copper. So let's look at this. First thing, figure out how much I should get. So here's my grams of aluminum. What do I need to do with my grams of aluminum? Change them to moles. And molar mass, I'm just going to go back. 3 is fine because this was given in 3. Then how do I get to copper? Look at your balanced equation. For every 3 moles of copper, I get out 3 moles of copper for every 2 moles of aluminum. And then, last part, what do I need? The molar mass of copper over 1 mole. So crunch all of those numbers, and what do you get out? 2.7 divided by 27. So if you can see that, that's a tenth, times 3 divided by 2 times 63.5. So if you look at that, you should get out, in theory, 9.53 grams. Okay, that's your theoretical of what you should get out for every 2.7 grams you put in. That's how much copper you should get out. Okay, but now we have to go and say, wait, I didn't get that much. You're not that good. You didn't get 100%. You're only 80%. So let's just plug in what I know then. Here's my 80%. Actual is my x. Theoretical now is 9.53. Don't forget your times 100. So now it's some algebra. Get rid of your 100. Divide both sides by 100. So what is that? 0.8 equals x over 9.53. Bring over your x. So to find 80% of 9.53, you're just multiplying it by 0.8. Hopefully most of you know that shortcut. I showed how you to do it. I just need 80% of my mass. And so you take your mass. What is 80% of it? You get 7.62 grams. That is your final answer. There's your final answer. So again, it's just another application of the stoichiometry. Okay, we're going to do one more together. As we're doing this one, what do you think of these new slides? Do you like the color green? Kind of, again, something bright, cheery, but I wanted to go with the white background because I think the white background's a little easier to see. And again, I'm trying to stick with the PowerPoints because I think those are easier to see than the Word documents. So kind of let me know what you think about them, but I do like the green edge around it. I like green. It reminds me of my Seahawks. Seahawk green. Okay, so let's go. What am I doing? Get focused again. Okay, water decomposed by the following reactions. I'm just going to balance them because I see something balanced. I need to balance it. So calculate the mass of HCl. Well, it wants in all the way here, but what did it give me? It gave me water in volume. And you're going, I can't do it. I quit. That's it. Nope, 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 no quitting. What do I know about water? What is the density of water? Remember, 1 gram, it's gram per milliliter. What does that mean? It means 1 gram of water is equivalent to 1 milliliter. So now what do I know? If I have 50 milliliters of water, that means I have 50 grams. So I have this. How do I want to end up to here? What is in common between these two? Yes, you're right, hydrogen. So that means I'm going to have to go to hydrogen, and then when I take this value of hydrogen, I need to go down here. But look, I don't get 100%, I only get 90%. So really, in this one equation, we're going to just do 2 separate problems. So let's kind of start here. Again, what am I going? From water to hydrogen. So what do I have? I have 50 grams of water. What do I have to do? Change them to moles. Molar mass of water, 18.0. Bet some of you even are getting those memorized. Then what do I need to do? I need to go to hydrogen. So what is it? 2 moles of hydrogen for every 2 moles of water. And then I need to get to molar mass. 2.02 grams for every 1 mole. So I do that, and how much should I get out? 50 divided by 18. Okay, look at this. Calculator, I don't need to do this step. 2 divided by 2 is 1. So 50 divided by 18 times 2.02. So I should get out 5.61 grams. Okay, cool, yay, I can take that. No, I can't. Look at only 90%. So come here and take 0.90% of that. So how much I really get in industry is 5.05 grams of hydrogen. So look what this is. Now this is just my starting point. This is how much grams of hydrogen I have. And now I can take this grams of hydrogen into this one. Okay, so now I want you to go ahead and you finish this problem. I'm going to give you a numerical answer. This is your final answer. And you can see how you did on it. So this should be your final answer. See how you went from here to this answer. I want to know how you did that and see the work as you're looking at that. So tomorrow we're actually going to do a lab, and it's a percent yield lab. Very, very similar to problem 13, that you're going to actually calculate how much you should have in theory. We'll see how well you did and how high of a percent yield can you actually get in the lab. How are your lab skills? So anyway, I will see you tomorrow. Have a great evening.